So no more spending time. Danila, good luck. Stage is yours.
Okay, thank you. So hello everyone, and let's talk on how to break the Python monopoly with Java. But first, let me introduce myself. My name is Danila Chechitov. I'm a senior software engineer at EPAM with more than 4 years of experience working in IT. And let's start. Here you can see our list of our main topics, and let's start from the first one. AI is overhyped but underestimated. It's an easy phrase, so let's dive deeper into it. And we can start from analyzing the market predictions. So Forbes says that the size of AI market can reach more than $400 billion by 2027. And they're expecting to see an annual growth rate of something about 40% from 2023 to 2030. On the not so bright side of things, they also expecting that AI will replace 400 million workers, but it will create some new jobs, like they're predicting that it will create 100 million new jobs related with the AI. And we already can see some changes on the market. For example, many firms are starting to hire people with, especially software engineers, with some experience with AI on AI-related positions. And we can see it also on number of AI patents granted from 2010 to 2022. And you can see a drastic growth, and it almost doubled from 2021 to 2022. And it also can be seen on the number of projects that are currently created. It says that it's 1.8 million, but I'm sure that it's almost the end of this year, and it will be something about 2 or even 3 million projects because they're growing with rapid speed. And it's also can be seen on the private investments. Because private investments in generative AI almost quadrupled from 2022 to 2023, and it's reaching $25 billion. And experts are predicting that the growth will continue. And they're making these predictions not because they want to believe it. They have a service that's showing that companies that are integrated AI solutions into the workflow, reporting the cost reduction and revenue growth. And it's easy to see how it's those two connected because they're saying that they have more than 10% decrease in the cost on service operation, manufacturing, human resources, risk management, and other. And when we are spending less money on such things that can be replaced by AI, we are receiving more revenue, and by this we can invest even more money. And in this circle, we can clearly see why private investments are so high. And not only by this, we also can see that number of AI-related degree programs are also growing because a demand on the market for specialists with AI-related experience, and there are specific positions for these people on the market. So universities are seeing that there's a demand for these degrees. They are preparing more and more engineers. So we have more engineers with more work experience with AI. Companies are receiving a greater cost reduction, they're receiving more money, so they're investing more money, and it sounds like artificial intelligence strong, and everyone should invest into it. And by saying invest, I don't mean that we should invest money. That's also probably a good idea. I don't know, you're the one to decide. But I'm saying invest time, because you need to understand how to work with it. As you can see on this graph, our field of work is highly exposed to AI. You can see it right there. And because of that, a person who has experience working with it will be much preferable for any employee than someone without any experience. And market is already showing how it's affected by the AI. There are some specific fields such as IML interfaces, smart devices, natural language programming. They're receiving a high growth in popularity, and there are a lot of new positions for people. But Other fields aren't feeling so well. For example, interface design, JavaScript, computer graphic, sales, they all fallen from the cliff. And not to follow them, we need to understand one important thing. AI won't take your job. It's somebody using AI that will take your job. And it's actually true because AI isn't some machine god that can do everything for you. It's just a tool, and you can see it on this graph. It can outsmart a typical person on several fields. It's better for image classification, visual reasoning, and English understanding. However, it struggles in complex tasks like competition level mathematics, visual common sense, and planning. So to repeat myself, it's not a god, it's just a tool that we need to know how to use to stay actually relevant and to keep our jobs with ourselves. And it's a really useful tool. And to understand how to use it, let's move to the next slide, how to AI. And let's start from the basic. Let's talk about AI-based applications. AI-based applications, like any application, consist of several layers. The first one is application. This layer handles everything from web apps to REST API, and most importantly, it allows user inquiries to underline machine learning models. And machine learning models, it's there on the model layer, and it's the core of decision making and data processing. This layer processes data from the application layer, performs computation intensive tasks, and return insights of what data should be presented or what action should be done. In some specific scenarios, when we're working with frameworks, this AI model layer can do some specific actions, and we will discuss it later. And during this conversation, we will focus mainly on large language models because they are most commonly used on the market and across every project. I will say the majority of them is about LLMs. Of course, there are a lot of different models, but we will keep an eye on LLMs during this presentation. And infrastructure model is a common infrastructure layer that manages CPU, GPU, and other resources. Let's not spend time on it. And let's talk about prompts. Prompts is one of our main tools to communicate with the model and to receive the response that we want. And there are different techniques, but let's talk about main four. First of all, zero shot, or as it's called, direct prompting. It's when we are just asking the model as a question without any context or examples. We usually doing it when we're asking some simple questions that can be answered without any preparations, like what is 2 plus 2? It will always give us a correct answer without any hesitations. One shot or prompt by one example can be used when we are facing some slight hard tasks, and when the model expects some context or some extra data to understand what we want from her. For example, we can ask some question like, give me the name for my cat, and please keep in mind that I loved movie from the 90s. And based on this information, it will generate a name of a cat with some links with the movies. And it's called one shot because we're given only one example. Few shot prompting is when we're sending multiple examples of data or multiple sets of data. And it's useful when we're facing some hard task and we want to receive a response following some specific pattern. For example, in our application, we want to convert a response into an object to work with it in our application. So how to do it? We provide model with a set of JSONs, which it should follow. And every answer from the model will be in these JSONs, which easily can be converted into objects, and we can continue to work with them. And for specific tasks, that's can require reasoning or multi-step problem solving, we can use chain of thoughts prompting. By using this prompting, we help model to solve the task going step by step. And we ensuring that it will do it by sending follow-up questions. For example, we can have some massive question about how to solve the world hunger, and we can send some follow-up question like think about where we will take food, how many people live on Earth, and so on and etc. And by following these follow-up questions, it will help the model to answer on the main question. And of course, other techniques like self-consistency prompting, meta-prompting, role-based prompting, and others. But for the sake of time, let's not spend too much time on it. And those prompts, of course, they're useful, but the majority of time you will be using these four prompts, these four type of promptings. And let's talk about why it's actually important to use prompts. There are several benefits of using prompts. It's increased efficiency. Because as you already know, we can return the response following the specific JSON pattern, and it will help us to save some time and line of codes and amount of errors that we are facing while we are manually converting data. It's a source integration because we can integrate our calls with different AI models and software components without any loss of consistency, and improves our flexibility. Uh, Based on diverse application needs, we can support different requests, and it will help us with rapid iteration and deployment. And speaking about deployments, it's also help us to automate a lot of different things. For example, inside the prompt, we can ask the model to make some actions based on the response from the previous requests. Like, for example, we can ask, based on this response, determine which API call, which API endpoint to call. And it will call the specific endpoint, retrieve some data, and based on this data, make an action, a different action. We will discuss how it works a bit later. And we can work, it can also does data transformation, structured output generation, and all of these things are really useful. But we actually want our model to work without our direct control. We want to have a tool that can help us to solve some high-level tasks. And for these specific cases, we use agents. Agents is a reasoning mechanism to solve complex tasks, as I already told you. And they usually consist of several components. Of course, different agents can have different names, but it's usually memory, which is responsible to store our conversation, planning, which is responsible for breaking down the high level task into smaller parts and answering them step by step. Prompt, as we already know what it is. Knowledge is a pre-learned information that will be used by LLM to get context information for our answer. It's something that model was pre-learned before. And tools. Tools is they're executable functions, APIs, or other services that can be reached by the model to make some actions to retrieve some data. And as you can see, in the center of an agent, we have LLM. This is possible for controlling every component. Some of you may ask me, why am I calling it agent? And you will be right, because we also have kernel for semantic kernel, function API for Spring AI. But I'm using agent because it's from the most widely used framework, from the default language for the AI, LangChain. And speaking about LangChain and Python, let's take a look at what our concurrent has and what its framework can offer, so we can understand what they have and what Java has. We could compare them, and it may help us to understand what should be done to break its monopoly. And on this graph, you can see four main frameworks for Python: LangChain for G, Llama Index, Out Again, and CrewEye. And as you can see, the Python has a leader. It's LangChain for G. It's the most commonly used framework, and it has second to the AutoGAIN amount of funding. And I will say that it has the biggest amount of funding because AutoGAIN isn't actually comparable to any other framework. It's Microsoft creation, so it has an unlimited money. And compared to any other open source framework, isn't fair. So let's dive deeper into each one of these framework to understand the cons, pros, and when to use them. It will help us to understand the state of Java currently. Speaking about pros, LangChain was specifically created for NLP tasks, or as they're also called, natural language processing tasks, such as text generation, translation, and summarization. And it offers a variety of pre-trained model which are easy to use. Out again is a Microsoft creation, so it goes from it. It's like all. It was specifically created to use inside the Microsoft ecosystem, and it thrives there. Llama Index was created to handle a wide range of data formats with indexes techniques to enable fast and accurate retrieval. And it's mainly used to work with various information sources to retrieve data from them. CrewAI gives us a possibility to build and manage systems with multiple AI agents working all together. It provides greatest flexibility among all other Python frameworks, and we can build a unique multi-agent system using any machine learning model. But of course, with all these benefits, there are some disadvantages. LangChain is highly limited to NLP-related tasks, and it may not be suitable for projects beyond these tasks. For example, if you will ask LangChain to work with documents, it can do it. But it's better to use Llama Index. And the same goes for Llama Index. If you want to create an application that will be responsible for working with big amount of data, like creating a higher level understanding of reports from your taxpayers or something like that, it's better to use Llama Index than LangChain. And for some other tasks like NLP-related tasks, Llama Index won't work so well. Out again, biggest issue is that it's Microsoft creation. So you never know. You never know when it will be paid to use. As for now, it's free to use, and it's kind of like open source, but you never know when it will be closed, and you will be pushed to pay for it. And CrewAI, the biggest issue of CrewAI is that it requires a high level of technical experience. You need to be able to set up and use your own machine learning models because it doesn't have a lot of pre-trained models. And if you will compare it to LangChain, it offers a much greater flexibility. But you actually need to know how to work with it, and it will require a lot of time to learn it. So to summarize it, we can say that each framework has its own strengths and weaknesses. And we can say that they sort of specialized and divided the market among each other. So each one of them has its own piece of cake. And it sounds like these frameworks, they're doing some magic. You can just use them and they will do everything for you. They can work with memories, they have knowledge, they know how to divide tasks into separate smaller tasks, they're following patterns by their own. But actually, it's not magic. It's just API calls with some prompt engineering inside it. So now let's talk about Java. We know what Python can offer, and now let's talk about it, about Java. Sorry, I have some. Okay, and let's start from the obstacles that Java is facing, and why it can be actually, as for now, it can't become a de facto leader as Python. And one of our biggest issues is library and framework ecosystem. Of course, there are some machine learning libraries on Java, but they are much less comprehensive and lack the same level of the community support that Python offers. And speaking about community support, Python has a vast and active data science community that continually contributes to open source tools, tutorials, best practices. If you will Google some tutorial about how to AI or how to use any framework, 9 out of 10 tutorials will be about Python. And it's not just because everyone loves Python. The reason for it is the Python offers a simplicity and consistent syntax, and it's easier to it's much more suitable for prototyping than Java. Java is an enterprise solution language. And because of it, no one wants to spend much more time and much more lines of code to achieve the same that they can do on Python. For an example, on Python, you can write some simple chatbot in 10 lines of code, I think, or something like that. While in Java, with all our frameworks, it will be hundreds lines of code. And because of it, we have a reason of industry adaptation and trends. Python has become the de facto standard for machine learning and AI in academic research and industry. And because it's the fact leader, we have more tutorials about AI, and because of these more tutorials, we have more community support, and it's like an infinite circle of Python going through the roof in popularity. And it may sound like we are doomed, and why we even trying? We can't do anything against Python. But actually, we have some assets that we can use. Let's talk about them. First of all, performance and scalability. Java has high performance and optimized runtime that provides consistent and efficient executions, making it suitable for large-scale high-performance application. And one of our biggest assets is that Java is widely used in enterprise systems. There are a lot of enterprise systems that are already written in Java, and customers that don't want to change anything in their technology stack, and they just want to continue working with Java. And because of it, we have a huge market without a clear leader and coherent solution. If someone, it's any company, will be managed to take the spot of Lang chain in Python, they will be thriving. They will achieve financial greatness forever. Because a lot of companies that are willing to spend money to to integrate AI into their Java application. And let's talk about some frameworks that you already have, because companies actually want to take this cake. And we have some of them. It's Spring Guy, Semantic Kernel, and LangChain4j. It may look like semantic kernel is a winner and everyone needs to learn semantic kernel as soon as possible. But in reality, it's a semantic kernel for every language. It's the main repository of a semantic kernel which contains semantic kernel for C#, for Python, for Java. And Java was separated not so long ago in July. And as you can see, it's not actually popular. It lies on the end of our graphic, and it's really hard to see who using it. And it's not because it's bad. It's a bit raw, but the problem is that it's new, and not so many people actually know that they have a separate repository for semantic kernel Java. Now let's talk about each one of these framework step by step to understand what we have. And let's start from semantic kernel. As you can see, semantic kernel also has different elements. And let's start. A semantic kernel has kernel, as it's called. And kernel orchestrates completion of user tasks. It's responsible for managing each and every component as a component. It's responsible for creating a plan. It uses Planner to create a plan which plugin should be executed, in which steps should follow after each step, and so on. It also works with memories, which are responsible for storing the memory of user conversation. It uses connectors to integrate to external data sources and plugins. Plugins custom native functions that can do a lot of work. For example, we can use them to retrieve some data from the external sources, like to call some APIs. We can use them to make some actions, for example, change something in our database, make some calculations, and so on. And speaking about possibilities of what semantic kernel can do, here's a comparison of semantic kernel for C#, Python, and Java. And you can take a look at it, and it's one situation at a time when Python and Java are on the same level of possibilities that any other language has more possibilities than them. Because semantic kernel is primarily focused on C#, and Python and Java for them is just side activities. And let's talk let's take a look at simple rack application. Simple rack using semantic kernel. And as you can see, semantic kernel is at the center of everything, and we have such thing as cognitive search. Some of you may know that usually with rack we are going into vector database to retrieve some data. And cognitive search is an Azure service that supports various data sources, including Azure Blob Storage, Azure Cosmos DB, and is responsible for data chunking, transformation, and cleaning. So it's like another level of abstraction above vector database, and nothing more. Now let's talk about the champion of the Python world in Java, LangChain for G. For G is like for Java. And as I previously discussed, semantic kernel, it also has different elements, such as agent. Which is responsible to guide what step to do next and makes a decision based on intermediate results. Memory is responsible for storing the conversation and the current state between runs of a chain. So yes, LangChain goes from its name, works with chains. What is chain? Chain is a construct sequence of calls. So it goes call after call until it reaches the result. As one example, we can make some call to retrieve some data. After this, we can make another call to make some computations, to calculate something, another call to evaluate our response, and so on. Retrieval is responsible for retrieval of information from external sources. Tools are usually used to integrate with external services, APIs, or making some calls. So it's the same thing as plugins for semantic kernel. And in terms of capabilities, it may look like Chain4G and LangChain has the same level of capabilities, but in reality, it isn't true. Of course, they kind of can do the same things, but the amount of tools they can use to achieve it is drastically different. And later you will see why I'm saying it. Here's an example of a simple rack using LangChain4G. Here we're working with vector database and we're using tools or functions to make some actions. And let's talk about Spring AI. Spring AI is a bit different from previous discussed frameworks because it's more like an extension of a Spring framework, and it's not as self-sustained as previous frameworks. But it still has different components such as models. So it's called like different components, but in reality, Spring Framework has a pre-built amount of models with which it can work. So you can, inside your code, you can just change a model, or inside your application YAML, you can change the name of a model, and Spring by itself will use the correct one. It also can evaluate AI responses. And it's actually a pretty useful tool which helps us to work with hallucinations and to evaluate what is our response. So it helps us to avoid a situation when customer asks about hotels in Brazil, and our application provides him with the list of best fishing spots in Amazon River. It will help us to understand what's going wrong. It also has functions which allow us to add some skills. It's the same thing as plugins and tools, as previously discussed frameworks. Memories to store our conversation, and has advisors. Advisors, it's pre-built capabilities that we can add into our model to make it behave differently based on our needs. As for example, memories are part of the advisors. And I'm saying memories because in Spring AI we have different classes to work with memory. For example, we can use memory summarization, and it will automatically create a summary of our conversation. So if you have a long lasting conversation with someone, and we know that it will take a lot of calls, and we don't want to store all this conversation in our memory, we can use the summarization, and we will store just a small part. And in terms of RAG, it's the same. So you can actually see the pattern that all these frameworks, they are kind of doing the same thing, but differently. And on a high level of abstraction, it's true. If we will dive deeper, we will see that they have different implementation, different patterns inside them. But on the high level, it's kind of the same. So because of it, we can say that it's hard to understand which one of them should be used and why. And that's why you need to spend your time to learn which framework is best suited for which particular task, and how to use the available capabilities of each framework optionally. And here you can compare main components. As you can see, they have different names. But they kind of doing the same thing, like agents, kernel, model, function chain, planar chains. Uh, they're doing the same thing. Of course, they're doing it differently. And when we will use them, we will see that the results of them are also different. But on the high level of abstraction, they're the same. And here you can see the code of how to add new plugins or tools into your application. And going ahead, I can say that it kind of looks like a semantic kernel, for example, requires only one annotation, but in reality, it isn't true. And for semantic kernel, if you want to add the function, it's not enough to just define it. You also need to add it into your model, and it requires some code to do it. While in Spring AI and LangChain for G, it's enough just to add an annotation. Especially Spring AI, because we're working with beans and it integrated inside the Spring framework. You can simply just add beans into your configuration and provide some description. And based on it, the model will decide whether or not to call this function. For example, in this scenario, we created a simple what is the bean that returns the weather in our location and provides the description, like call it when you want to receive information about the weather in this location. So if the customer starts asking about the weather, the model will just call this function and response. It will retrieve the information about the weather. It goes the same for every function and tools and plugins. Again, it's all the same. It's kind of the same. And let's compare Python and Java frameworks side by side to see the difference in their popularity and to understand what is going on currently. As you can see, it's easy to spot the Python frameworks. It's like all three of them on the top are Python frameworks. And the biggest reason of this drastic difference is that Python already has a huge ecosystem of libraries and frameworks, specifically for AI and machine learning. Of course, AI also has these libraries like deep learning for G and others, but The biggest issue for us is that we don't have the same level of community support as Python. But as I already told, we still have some assets, and for simple API calls, Java works just as well as Python. But unfortunately, as for now, Python used as default everywhere. And some people can ask, what about running LLM locally? Of course, it's possible to do with Java. We have some options like Llama CP or Llama Java, but Python offers significantly more solutions with broader support and optimization. But from my point of view, I wouldn't say that it's actually necessary to do it on Java because Java thrives on different ways. We are a language for enterprise solutions. So when we're talking about enterprise, we usually follow model as service patterns. And AI models are mostly commonly deployed as external services, for example, in the cloud. These ways, the models themselves can be written and run in Python, C Sharp, .NET, or any other language. It doesn't matter. We can communicate with them through API, and by doing it, this removes the language constraints. And on the majority of enterprise applications, the primary goal isn't to run AI models on the platform, but to use them efficiently and integrate them with other systems. And this can easily achieved throughout existing API or the frameworks that we already have on Java. And because of it, we can say that instead of focusing on the language in which the model runs, it's important to understand that enterprise applications in Java can efficiently use AI models developed and tried in Python, Java, in Python, C Sharp, or even on Java, .NET, it doesn't matter. And we can integrate with microservices, external services, APIs without any issues. It's the whole point of using Java. And before the end, let's compare the capabilities of Java frameworks with LangChain framework in one of the essential aspects, data connection or data retrieval. And we can see a drastic difference here. For example, LangChain4j, Spring AI, most of them have like 10 different document loaders, while Python has over 100. And I add a semantic kernel for Java here, just to make LangChain4j and Spring AI look better, because this boy can only work with Word. Of course, maybe something could change. For example, when we are creating a learn when we're creating a course on Learning Portal for semantic kernel for Java, we were almost done, and then semantic kernel pushed a new version as they changed a lot in the implementation, in the capabilities, and we were pushed to redo everything. So maybe now they have some different loaders, but I'm sure it's far away from LangChain capabilities. And we can say it about any other site, vector stores, text embedding models, actions to retrieve your data. It's just they just have overwhelming amount of tools that can be used. So yes, some frameworks in Java, like LangChain4j or Spring AI, can do everything that LangChain for Java for LangChain for Python can do, but the amount of tools is much lower. And it's kind of an issue, but it gives us another question. Are we actually ready to work on enterprise? And to answer this question, we need to understand some issues that our application are currently facing when we're talking about enterprise. First of all, cost of tokens. Tokens for GPT-4 are very costly, and chain frameworks consume them with the speed of light. Hallucinations. Dealing with the hallucination is an art, and it's hard to do without any experience and understanding of what is going on. You can just simple add in a prompt like something, do not hallucinate, and hope that everything will go fine. For every decision that you are making, for every action that you are adding, you need to constantly think, how does this affect hallucinations? And even if you were able to do everything right and your application works perfectly fine, um, any new feature can break it. And that then ingestion issues. On paper, processing and ingesting PDF sounds simple, but when you get into production use and import thousands of documents and web pages, you have an issue of trying to understand is each document accountable with a clear audit log? Is the pipeline resistant to failures? How do we refresh or reprocess the documents? And there's a reason why LangChain has 5 different PDF parsers, and almost nobody knows which one to use and when. And the reason for this issue that nobody knows what to use is rapid changes and documentation issues. The API of every framework is constantly developing and changing. So you should constantly be ready to fix breaking changes for every new feature. And it's a big pain because when you create your application and they just push on a new feature, customer asks you to please use a latest library, and you are just spending weeks to making it just start work. Because the API is changing, the inside logic is changing. Uh, there are a lot of things that change constantly. And because of that, it's important to know the tools and be able to use them. Different tasks require different approaches, and ready-made solutions aren't always available, and sometimes you need to create your own. And that's why you need to understand how framework work in general, how to adjust them, and to fit them into your own solutions. And you need to know best methodologies, approaches on how to work with AI, especially you need to know prompting and different patterns regarding how to build an application and how to create an architecture of this application. And I hope this presentation will give you some hope in Java and motivated to learn what Java can offer in terms of working with AI. Or even it will motivate you to expand Java capabilities by actively contributing to the development of some frameworks that you like. I will suggest to contribute to Spring AI. It's my favorite framework in Java. So thank you for your time and for attention.
Thank you. Thank you very much for great presentation. We do have a couple questions which I would like to ask you. First, to start with, from my side. So you mentioned that you like Spring AI and you're a fan of that. But still, I will ask my question. If you would need to develop new project to start from scratch, which framework would you use to
Actually, it
implement your AI?
depends on what client wants to achieve because, as I already told, different frameworks different give you different capabilities. And as de facto, I would suggest to use Spring AI because it's easy to integrate, it's easy to prototype. But for some specific scenarios, if it's want to work with different models, some frameworks, Spring AI, semantic kernel, LangChain, can have already pre-built models to work with it models and it will be easier to integrate. And you won't need to create a new model by yourself and to integrate with it.
Okay, okay, thanks for the answer. Just a small disclaimer before we proceed with questions. Today, the fourth talk of the day would be from Przemysław, where he would show more in deep usage of these libraries, which were mentioned by Danila in his talk. So if you want to know more how to do really code in these libraries, stay tuned. In a couple hours, we'll be here talking more, having another dive into these libraries. So stay with us. So coming back to questions. Thanks for the presentation. What do you think about applicability of other JVM-based languages for AI development? Which of them could be comparable or better than Java from your standpoint? And take into account that the libraries can be used from all of them.
Could you repeat your question, but a bit slowly?
Yeah. So okay. So question is, what do you think about applicability of other JVM-based languages like Kotlin, Scala, etc.?
Mhm.
And which of them could be comparable or better than Java for AI development?
In terms of what is better for AI development, I can say is that it's better to use Python currently than Java. But in terms of is it better to use Scala or any other, as far as I know, there are not so many frameworks for them. It's already existent, and you will be needed to work by yourself and to write kind of your own framework. Of course, I may be wrong, but if we're talking comparing JVM languages, it's better to work with Java, from what I can say.
Okay, totally makes sense. One more question, a bit more tricky, and I think dependent on the name of your talk. So, to develop projects using AI is fine, but the models and LLMs are being developing using Python. So, how will Java will break Python?
Yeah, as I already told you, we can use these models, but it's not important. It doesn't. We shouldn't work with these models with Python. Models can be run on any language: Python, C Sharp, .NET, any other language, even on Java. For us, the goal of Java is to integrate with these models. So model can be run on any language, but on enterprise solution, we can work with Java. There is no need to try to push into enterprise Java application some blocks of Python code to make it work with AI. We can integrate it with just using Java code, and this model can be run on any language. We will just communicate with it using API calls. On actual enterprise applications, those models are written on Python. They usually deploy it on cloud. So for us, it doesn't matter what language it is.
Yeah, I can just add to the answer Danila provided that Java is really great language for integration. I mean, GVM, right? The whole ecosystem is a
Mhm.
really great for integrations. So when we have several systems which we need to integrate, doesn't matter what is the systems, is database, front end, AI, and whatever. Java is really great there, and there is a lot of tools and libraries to do this integration. So I think that this could be the place Java uh, in the AI world, and this is what we can really tend to and work with. Uh, okay, so one more question. Do you have any projects where you already applied Spring AI for production, or it's still in POC phase?
Actually, the majority of our applications, they are on POC stage. A client goes to us, asks for POC to show how it works, and we are creating this POC, and then they are just using it as for now. And the majority of these projects, they are for 2 or 4 weeks. It's not a long assignments. So it's not like an actual enterprise decisions, and it goes from previously mentioned problems with the enterprise, especially with the cost of tokens, because it's really costly to have an enterprise decision with current costs of tokens.
Okay, thanks for the answer. So I assume this is it. So I want to thank you for a great talk, for being with us on Java On. Thank you very much. See you on future conferences.
Mhm. Thank you. Have a nice day.
So, guys, we are moving on with Java, with our conference, Java On. So, we are a bit ahead of time. So, we would have a small break because we have two talks ahead. So, we would have this small break, 5 minutes. Use it to fill your cups with the tea. I will do same. So today I am a bit better with my cough, so I think I will not disturb you a lot with that. So 5 minutes. We will be back with our next speaker. Stay tuned. Don't turn your YouTube off. We will be back very, very, very shortly with you.